Hello everyone, this video will demonstrate finding the probability using Argv-in function for different distribution, for example, normal distribution, chi-square distribution, t-distribution, and F distribution. Let's start with the normal distribution. For normal distribution, in order we want to find the probability value, we can use p-norm, and inside the parentheses, we put the value of our x, followed by the mean and the standard deviation. For example, let's say that a light bulb's life is having a population mean is 1,500 with standard deviation of 120. A pack of n equal to 16 is purchased. So what is the probability that the average life is at least 1,550 hours? To do this, we try to gather all the information given just now. So give you the new value, which is 1,500, and the standard deviation value, which is 120. And then the sample size is 16. So for this one, we need to calculate the standard error because the standard error, because the standard deviation given, which is the 120, is for the sigma. So we need to find the standard error for the sample mean. That one is for the population. This one we need to find for the sample mean for our X bar. So standard error can be calculated as standard deviation divided by the square root of n. So we want to find the probability. So P norm, our X is 1,550, mean is mu, and our standard deviation is standard error, which we just calculated just now. And since we would like to find the probability of greater than, it is the upper tail, so you need to add lower dot tail equal to false, because by default lower dot tail is equal to true. This one is for the probability of less than. If we want to find the probability of greater than, then we need to add lower dot tail equal to false. So we will get 0.0477. You can round off this value if you want. Okay, just round off the value. And we put it here. So round probability Z. Maybe you can round off to 2 decimal places. Okay, then to run it. Okay. If we run off to 2 decimal places, we will get the probability of sample mean at least greater than and equal to 1,550 is equal to 0.05. Okay, now let's take a look at chi-square distribution. For chi-square distribution, just use p chi-square in bracket q and df. Q again is a value for the x, the chi-square value, df referring to the degrees of freedom. A machine fills back with weight of the mu equal to 500 and sigma equal to 4. A sample of 10 bags taken. So what is the probability of the sample variance, which is S square, is 30 or more? So first of all, we need to gather the information given. Give you the new value, which is 500, and the standard deviation value given is 4. Since we're looking at S square, because after this we need to calculate the chi-square value, so it requires you to have the S square value. So okay, our sample size equal to 10 and S square is equal to 30. Okay, now let's calculate the chi-square value. So what we call the formula is n minus 1 multiplied with s square divided by the sigma square. So n minus 1, you can simply put 9 there because 10 minus 1 is 9. Or you can also do like this. Doesn't matter, okay? It doesn't matter as long as you understand. Okay, multiply with s square because everything you already defined earlier. Okay. Let's obtain the value for the chi-square first. Okay, 16.875. So this is the chi-square value. So chi-square. So the value is chi and then followed by the df. Okay, so the df is, you can put df is 9, right? Okay, just straight we put 9 there. Okay, and since this is also the question wanted you to find the probability of greater than, right? Greater than. So you put lower dot tail equal to false. So you get 0.07. Okay, let's round off this one. Okay, let's round off round probability chi to 2 decimal places. Okay, and then just run. Okay. Okay, that one is for the chi-square value. Now let's take a look at t-distribution. For t-distribution, we use pt in bracket q and df. Again, q is a t-value and df is a degrees of freedom. For example, a sample of n equal to 5 is taken from distribution of mu equal to 100 and variance is sigma squared. So what is the probability that the t statistic will exceed 1.533? So this one you can straight away, because the question just want the t value is already given, right? The q value for q is 1.533. Df is 4 because 5 minus 1 is 4. And since it want the upper tail, so lower tail equal to false. Okay, 0.1. So let's put it here. So let's round our value, probability value, round PT. Maybe this one, if you round to 2, 3, 4, you will get the same value, which is 0.4. Unless you round off it to 5 decimal places, then you will get 0.10002. But this one, I think I just want to have a 2 decimal places only. So I just put it 2 there. Oh, sorry. What happened? Oh, um, what happened? Okay, let's see. Where is the mistake here? Oh, sorry, not PT. Um, Prop T. Ya Allah. Okay, Alhamdulillah, 0.1. Okay, so next we go to F distribution. For F distribution, if T we use PT. So F we will use PF. So for F distribution, you will have 2 degrees of freedom. So inside the parentheses, you put your F value followed by the first degree of freedom and the uh, the second degree of freedom. For example, okay, we try to look at this one. What is the probability that S square 1, which is from a sample size 1 equal 25, will be more than 6 times, okay, S square 2 from a sample size 2 equal to 5. Assume that the population variances are equal. Okay, so this one and 1 equal to 25 and 2 equal to 5. It's okay if we do not want to declare this one because the DF is calculated as N1 minus 1, right? DF2 calculated as N2 minus 1. It's okay. This one is okay. Okay, and then we want to find the probability of F greater than 6. So just put it away. PF, okay. The value is 6. DF1 for DF2. Since we want it, we want the upper tail, so lower dot tail equal to false. So we'll get 0.0468. Okay, so here I just put it here. I want to round off it to maybe this one. I would like to round off to 40 decimal places. Okay, so 0.0468. Okay, thank you.